This recording captures one of three presentations delivered on March 31st, 2021 to members and guests of the Waikato Branch of the New Zealand Institute of Primary Industry Management. The aim is to extend the relevant science and understanding of organic soils with farmers, agricultural advisors and rural professionals to support effective management of peat soils.
So I'm going to give you a quick overview of what the three of us are going to talk about today. So I'm going to give an introduction to peat soils in the Waikato region and give an overview of peat subsidence. Then after me, Dave Campbell is going to speak about greenhouse gas emissions from peat soils and recent research from dairy farms in the Waikato. And then following on from Dave, Jack is going to speak about mitigation options to reduce subsidence and carbon loss from peat soils, and then a discussion on future research direction. So let's get cracking. Right, the first thing is what is peat? Okay, so peat is an accumulation of partly decomposed plant material formed in a wetland environment. So you have a situation in a wetland where the water table is high, and the high water table prevents the breakdown of the plant material, and that accumulates over time. And in our region we have some quite unique species, Restiad species, and they're able to limit their transpiration or evaporation, and that means we get peat soils in areas where they otherwise might not form. So the image here is of a peat in a wetland, and the one here is probably a peat we're more familiar with. This is a peat soil under pasture, so it's been drained and oxidised. The soils we find peat in are actually called organic soils by, the soil science community in the New Zealand soil classification. But often the term peat soils is used in policy, in literature, for example fertiliser and effluent application. We often talk about peat soils, but generally what we're referring to is organic soils. But for this we're just going to continue to talk about peat soils. So peat soils are interesting. They're characterised by high organic matter content, low bulk density, weak strength and high shrinkage. So in the Waikato there's about 89,000 hectares of peat soils. So the map here, all the green areas show where the majority of the peat soils are in our region. So as you see, they're mostly in the lower Waikato, the Hamilton Basin and the Haraki Plains. Now the peat soils in our region, they represent 40% of the national resource. So in the Waikato, we have the lion's share of the peat resource. There's other areas like Southland, Northland, the West Coast, that also have peat as well. Now to be an organic soil, or a peat soil as we're calling them today, they need to have at least 30 centimetres of this organic material. But in some places our peat soils are up to 12 to 14 metres deep. So if you step back in time and you flew over parts of the Waikato region, this is what you'd see. And so this is the Kapuatai peat bog on the Haraki Plains, and it's the largest remnant of, a Restiad raised peat bog in the country, and it's a site of international significance. But however, from the late 1800s, we did what we were doing all over the country. We were clearing land for productive purposes, and this is what we were just doing at the time. And it wasn't wrong, it was just the way it was. And so this image here is of the Mokoro Line Canal on the Haraki Plains being dug in 1910. And so much so that there's even an act of parliament for the drainage on the Haraki Plains where it was promoted. So yeah, it was pretty much just what we were doing at the time. So this extensive artificial drainage has allowed these peat soils to be used for production. So this map here shows, the current land cover on our peat soils now. So the red areas represent areas which we could term as being undrained, so they're still as freshwater wetlands, and there's about 19,000 hectares. But arguably some of these areas are impacted by drainage. And then also we have the drained areas. So it's about 70,000 hectares in total which have been drained, and this is dominated by pastoral agriculture. So that's the green areas on this map here. And then we also have cropping at about 1,100 hectares, although interestingly the cropping number here probably doesn't represent all of the maize crops that are put in probably for pasture renewal. We also have orchards, so there's about 300 hectares of those, and they're dominated by the high value crop blueberry production. And there's also other areas of drained peat soils as well. So for example, along Kaikatea Drive, we have an urban area of peat soils which have been drained. We've got a peat mine and various other bits and pieces. But I think an important thing to point out, these drained peat soils are now a significant contributor to our regional economy. And I haven't run the numbers, but with about 67,000 hectares of peat soils under pastoral agriculture, probably predominantly dairy, I wouldn't be surprised if that represents about 10% of our dairy land use. So quite a significant and important feature in our regional economy today. So the drainage of these soils varies. So in areas, these peat soils around here, around Morrinsville, Te Awamutu and Cambridge, they're drained by gravity, so the drains are dug and the water just drains away by gravity. In other areas, like on the Hauraki Plains, where they're lower, and also you have the tidal influence in the rivers, drainage is a bit different. When the tide's out, they'll just drain by gravity. When the tide's in, the flat gates will shut on the river, and that will impact on drainage. The gravity drainage will stop, and if those rivers are in flood, then they'll need to use pumps to get the water out. And then in other locations, like the lower Waikato, and in some areas, in the Hauraki Plains, they need to use pumps more often because that land is even lower. One thing is, with the drainage of our peat soils, this leads to land subsidence, which is a gradual lowering of the land surface over time due to drainage. So I'm just going to now talk about, just broadly about the subsidence process and some of the subsidence rates that have been measured in our region. So here we have quite simply, I apologise for the simple diagram, we have a wetland here with a high water table. We've got our native vegetation that's limiting transpiration, it's not decomposing, and this peatland is accumulating carbon and slowly growing at about 1 millimetre per year. So an example of this now could be Kapuatai wetland on the Hauraki Plains. And then of course, that peatland is drained. So with drainage, we lower the water table and a number of things happen. So initially, we get quite rapid subsidence. And this is dominated by two processes of shrinkage and consolidation. So shrinkage occurs above the water table, where you lower the water table, and that dry peat, the structure of it essentially collapses. And then consolidation occurs below the water table. So now, because the water table has been lowered, that peat below the water table is feeling the weight of the peat above it, and it consolidates. So that's quite rapid initially after drainage, and it will continue, but it slows down over time unless there's significant drainage upgrades. Now another component is oxidation, and Dave Campbell is going to talk about this in quite a lot more detail. And so what happens is when we lower the water table, air can get in and microbes can now start breaking down that organic matter, and as a result of that we get carbon dioxide emissions, which are a greenhouse gas. So from now on I'm just going to talk about the general rates of subsidence that we see due to these processes. And Dave will continue after me to talk about the greenhouse gas side of things. So there's been a few studies looking at subsidence across the region. Probably one of the most significant ones was undertaken initially by Malcolm McLeod in the early 2000s and then Jack Pronger in about 2012. So in the 1920s, when the areas of Maina, Tuatua, Rukahira and the Hauraki Plains were being drained, the drainage engineers had to take peat depth measurements. And then in the early 2000s, Malcolm McLeod from what was then Landcare Research came back and remeasured these peat depth measurements, which were a series of peat depth probes within all of these peatland areas. And so what he came up with was an average subsidence rate per year for each of these areas, and if we average all of those areas, it equated to about 2.6 centimetres per year. And then in 2012, Jack Pronger returned to these sites and undertook those peat depth measurements again. And so for the period 2002 to 2012, he came up with an average annual subsidence rate as well, which across all of the sites and all of the measurements was about 1.9 centimetres per year. So a couple of things to observe on this graph here is that the higher rates initially, they probably include that initial rapid subsidence that occurred when the peatlands were drained. And also we see here that the Hauraki Plains is initially lower than all the other peatlands, and at the time it was thought that this was perhaps because the Hauraki Plains was drained a lot earlier than Maina, Tuatua and Rukahira. So perhaps we're not seeing as much of that earlier subsidence which perhaps occurred before the 1920s. But anyway, the take-home message from this is at the moment, generally, broadly, we say peat subsidence on our peatlands is about drained peatlands is about 1.9 centimetres per year, or you could say 2 centimetres. So the thing is that with 2 centimetres of subsidence every year, we'll lose about 1 metre of peat every 50 years. Now, I'm sure we've all seen images like this. So this is an example of a water tank that was probably put in about 40 to 50 years ago, and there's been and it's had piles rammed down to the hard stuff below, and of course the peat subsided around and now it's sitting 1 metre up in the air. So we see cow sheds on Valentine's Road, houses that need new steps, infrastructure being damaged. And the key is that this subsidence, and also the carbon loss associated with that subsidence, will continue so long as the peat is drained and until it's all gone. Now there's been a few studies that have been done over the years in the Waikato region that have looked at some of the controls and subsidence rates, and Jack will go into more detail about these when he's talking about mitigations later on. But just quickly, so one is time since drainage, so what I was talking about before. So initially we get quite rapid drainage. So what Jack did is initially we get quite rapid subsidence, and that slows over time. So what Jack did is he took his measurements of a 2.6 from Malcolm McLeod and his 1.9 centimetres and compared them to other studies from the rest of the world. And I guess that generally showed that with time, the subsidence rate decreases. Also, back in the 70s and 80s, there was a Ruakahia research station, a chap called Frank van der Elst, who did a lot of work on peat, and he did some work and showed that those peat soils with a higher mineral content or a lower organic matter content generally subside slower than those with a higher organic matter content. And in about 2005, the Waikato Regional Council did some pretty simple work that showed that deeper drains and more closely spaced drains generally cause greater rates of subsidence. There's also been some reporting back in probably the 70s and 80s talking about the rates of subsidence under cropping. And in those reports, they estimated numbers are about 7 centimetres per year. So that's considerably higher than the 2 centimetres a year that we talk about in terms of average rates of subsidence under, I guess, pasture or just generally. But the challenge with these numbers are, whilst they're reported, the field studies that go with those, we can't really find that information. So we don't really know how valid this number is. And of course, burning peatlands, well, if we burn them, they drop quite quickly and we lose a whole lot of carbon at the same time. So unfortunately, peat subsidence has consequences. So it decreases drainage efficiency, for example. So this causes a decrease in drainage gradient. It impacts on pump station performance. So this example here is from Phillips Road in Ngatea, or the Muggeridge's catchment, which has received a lot of publicity lately. So in this catchment, we've got peat subsidence occurring, and we've got issues with, I guess, drainage efficiency and a pump station which is struggling to cope. So when we get heavy rainfall, this area has quite significant ponding for a considerable amount of time. In some catchments, we also see uneven subsidence, where part of the catchment is subsiding faster than the rest of the catchment, which causes problems for drainage as well. Also subsidence, I guess generally with this drainage issue, results in the peat being wetter for longer, which of course impacts on production. Perhaps in some locations, subsidence could be, in the long term, could be further compounded by sea level rise. Also greenhouse gas emissions, which Dave will talk about, so the subsidence is contributing to our regional greenhouse gas emissions. And another question is around wetland sustainability. So, for example, there's a wetland in Moana Tuatua between Te Awamutu and Cambridge, which is surrounded by subsiding farmland. And I guess the question is, how sustainable is that wetland in that situation? So now taking a look at what current policy exists in terms of, I guess, peatland management and subsidence. So I'm sure we all know this guy here, the old Waikato Regional Plan. So at the moment, there's no guidance in the Waikato Regional Plan for the management of agricultural peatlands. There's rules around drainage near wetlands, so you need a consent to undertake drainage within 200 metres of a wetland. We have good practice guidance, so this document here, called For Peat's Sake, was put out by the Peat Management Advisory Group in '99 and then refreshed in 2006. So this has some really good information, but arguably some of it is perhaps a bit out of date, and also perhaps we need to test some of it. For example, how practical is it to block drains to slow subsidence, especially in upland peatlands, for example like at Moana Tuatua and Ruakahia. But probably an important piece of policy is what we call the Waikato Regional Policy Statement. So this sits above the regional plan and is supposed to inform the regional plan, Now there's a section in there about peat soil, section 14.5, and this suggests that we need to manage the adverse effects of use of our drained peat soils, and we need to somehow slow the rate of subsidence and carbon loss from those soils. This policy's been around for quite a while, but I guess what that's doing is this recognises the issues that peat subsidence poses, and I guess it encourages us to try and deal with them. And another thing is we need to think about what's coming from central government. So I'm sure many of you would have heard of the Climate Change Commission report that's just been released, and there's a section in there that talks about needing to account for these greenhouse gas or carbon losses from our peat soils. So Dave's going to talk about how these perhaps are already been accounted for in some way, but the question is, what does it mean if all of a sudden we need to mitigate for these losses, or if we have to pay for them? So, thinking about what we're doing now, so we know that ongoing peat subsidence will cause problems for land and drainage management, but we also know that production from peat soils in our region is an important contributor to our economy. And I've heard people, Annie, for example, has termed this as a wicked problem. And so how do we respond? I mean, for me, I think that it's really important that we understand the long-term consequences of subsidence. Where are those areas which are most at risk? And what does it mean for our communities? And looking at current policy, so the RPS, we need to think about ways whether we can reduce subsidence and carbon loss, which is what Jack will be talking about. And then thinking about the longer term. If we find that perhaps reducing subsidence is not a viable option, or we're just tinkering around the edges, then perhaps what are some of these longer term options? Do we need to think about other land use options? This is further down the track, but it's something that we all need to consider as a collective. We need to consider all options for the management of our peat soils. But it's clear, we need to improve our understanding of peat soil subsidence because we lack robust information on the effects of land use, land management and drainage on subsidence rates. So for the Council, to improve the information that we have, one thing we can do is we can use our requirement to monitor the state of the environment to start to learn more and build a baseline of information on peat subsidence. So, our current understanding of regional peat subsidence rates is largely based on peat depth probing points. This is problematic in terms of the numbers we get because it's quite labour intensive. So Jack here often complains about his sore back after doing a few hundred of these depth probing points down to 10 or so metres. The points are biased because a lot of them are based along drainage lines, and the inaccuracy of the measurement method means that it takes a long time for us to do repeat measurements where we can be sure that what we detect, to actually have a chance of detecting any differences in subsidence rates. So we have an opportunity to develop a monitoring network to provide good baseline data. And what I mean by that is set up a network where we can take into account the different land use on peat types, the different drainage management, different peat depths and peat types, and set this network up, and also give us an opportunity to see the effects on peat subsidence of perhaps this whole-scale land use change, or even the effects of climate change in the future. So we reviewed a range of methods to do this, and one we came up with was called light detection and ranging, which is LiDAR. So essentially all that is we fly a helicopter reasonably low and reasonably slow over our peatlands, and it uses a laser, and it records the measurements from that laser, which from that we're able to, develop a model of the ground surface. Now if we repeat that every 5 years, we can see how the ground surface is changing and estimate subsidence rates. So we can't cover the whole peatland area with this method of LiDAR, because it's too expensive. So what we've done is set up 12 transects across the region, covering about 11,000 hectares of our 70,000 hectares of drained peatland. So this image here shows our peatlands, and the map shows that all the different things we considered when we decided where to put those transects. So it's a heat map, taking into account land use, drainage management, peat types and peat depth. And essentially those areas that are red, they meet our sampling requirements the best. And so our transects are these black areas here, and this will be flown in April 2021 and then again in 2026, and that's when we'll start to get results. So it will take time. Another thing we're doing is when we were setting up the peat subsidence monitoring network, Dave Campbell from the University of Waikato said, look, natural peatlands oscillate, so they go up and down with the seasons. And there was questions whether, well, if drain peatlands do that too, that's going to impact on your subsidence monitoring. So this is something you need to think about. So Dave and his team set up some what we call peat surface oscillation monitoring sites in 2 locations across the region. And essentially, I'm not going to go into details, but it uses water table level to monitor the continuous ground, to monitor ground level surface and its changes. So there's been 2 sites running, and this is just the data from those sites to date. So there was 2 sites, Farm A and Farm B, and the black lines represents the ground surface level for each of those sites. We have change in peat surface elevation and also the months down the bottom there. So we see from about March 2019, or late autumn, the start of winter, the peat surface rose as the peat got wetter until about October 2019. And then in early 2020 we had quite a reasonable drought, quite a reasonable dry period, and we saw that the peat surface dropped again about 8 centimetres or 80 millimetres. And then perhaps we didn't have a particularly wet winter, so it rose again 40 centimetres. So essentially what we found is that yes, that the peat surface does oscillate. So what that means for us, for our LiDAR monitoring, is that we need to make sure that when we do our repeat measurements, that we do them at periods which are similar. So we're planning on doing our monitoring at the lowest point every time. So every 5 years we'll do it when the peat's at its lowest. Because if we're looking at 2 centimetres of a change a year and we were to monitor here 1 year and here another year, that could have a confounding impact on our results. So it was quite an important thing to consider. Because we're continuously monitoring ground surface levels, so getting really good data, we can use this to perhaps look at the impact of land uses on peat subsidence. So what we've done is we've used this method to see if we can detect differences in subsidence rates between land uses. So we've established 8 of these sites across the region, and we've got 4 on dairy farms and 4 on blueberry farms. And I guess what we want to see is we're going to leave these in for a number of years and just see where there is a difference between these 2 land uses. And we hopefully plan to install another 2 sites, one on dairy and one on blueberries. And also in the future we'd like to have a look at cropping as well, but a different method's required to do this. So just to summarise, the Waikato region has about 89,000 hectares of peat soils, and the majority of these have been drained, and the dominant land use is now pastoral agriculture. But like I said, this is an important contributor to our regional economy now. But unfortunately, drainage causes subsidence, which is about 2 centimetres per year, as well as greenhouse gas emissions. And unfortunately, this subsidence will continue so long as the peat is drained and until it's all gone. There are issues associated with subsidence, and these are likely to become more apparent over time. And we need to respond. We need to understand the consequences, we need to better understand subsidence, and we need to identify possible mitigations and whether they're actually practical for implementation. And also we need to take a longer term view and consider other options as well. Thank you.